Okay, so I hope you can see it well, can you? Yes, it is on the board, and you just try to scroll at the right side. Just try to drag the board at the right side. You will find it out. Okay. And over here, you have to solve the inequality, and you can see that all these questions contains just one variable. So this is, and on this one variable you are having power 1, maximum power 1. So this is a linear inequality of one variable. In other words, you can also call it univariate linear inequality or monovariate linear inequalities, like that. Okay, so you have to find out the solution, and also you have to express it on a number line. Okay, and they have also asserted here that some of the inequalities are not containing any solution, so we have to find it out once when we just cover up the questions. Okay, so let's begin, and I just select here a couple of questions, and I'm going to do this question that I'm going to take here. That's what I'm going to do. Okay, and 25 and 27, all right, and 36. Okay, so I am covering just less than, also just greater than, equals to, greater than simply, and less than only. Okay, so I must select one less than and equals to question 2. It's 38. Okay, so I have covered simply less, simply greater, less than and equals, greater than and equals. So I have covered all these types here. So let's begin and try to do it one by one, and we are going to express our solution on number line as well, because you know well that in linear inequality the solution is not unique. You're supposed to be having a range of solution. Okay, so you are having infinite solutions. All right, they are going to that are going to satisfy your inequality. So once when we talk about our question number 21, once when we talk about this, so over here we are going to simplify. You can see that it is having negative sign at both sides, so that you can cancel it directly, and this is it. Okay. Okay, so whenever you multiply both sides of the inequality with a negative number, or you divide both sides of the inequality with a negative number, the inequality swaps every time. You can see the example here. That's what happens. Okay, now let me just undo this example and let us move on with the question. So over here, if I multiply both sides by my negative 1, the sign is going to be reversed. Okay, so it becomes 2x less than 3. So x will be 3 by 2. X will be less than 3 by 2. In other words, x is less than 1.5. So all those numbers which are less than 1.5, once when you substitute it in this inequality, the inequality sign will remain preserved. I mean, the inequality will remain satisfied. Okay, so now we are going to represent our answer on a number line. So how you draw a number line? That's a number line, and you can see here that 1.5 is not included. You're simply having less than option. Okay, so you're going to put a hollow circle on your 1.5. So if, for example, I say that you are having 0 from here, no, 0 is here, this is your 1, and this is going to be your 2, okay, and this is your 1.5 in the mid, okay, and from here you're having all the negative numbers. So you're going to put a hollow circle on this number 1.5, and then you are going to highlight the left side of your 1.5 either with a different color like this, or you can shade the region. You can shade it like this. Another way is to overlap the number line. Okay, so another way is this, and I like the second method much more. So I'm going to use a different color, and I will just enhance my stroke. And that's how I represent. So all the numbers which are at the left side are definitely less than 1.5. They're all included, and that's how you do. Okay, and 1.5 is not included. That's why you put a hollow circle. And if you are having an option like this, then this 1.5 is definitely going to be included. So you are going to put a solid circle on it, on a number line. Means that this number is also included, and it is also going to satisfy the inequality. That's what it means. Okay, so just to check that is your answer correct or not, you just pick up any number which is on this red line. If I pick 0, for example, 0 is less than 1.5, you know well. So if you just substitute 0 here in this inequality, is it getting satisfied or not? Let us check it. You see that if you put 0 is greater than -3, yeah, that's right, it is satisfying. So you can put all the values which is on the red line. It is definitely going to satisfy that. That's how we do. It means our answer is entirely correct. We just perform a check here. Okay, so let us move on and see the next question. I hope it's clear, is it? Okay, now let's see the next question. Question 25. Okay, now 25 is here. So let me make a proper margin so that we could make a difference. Okay, I'm going to do the work here. Okay, my 25 says that 2x plus 7 less than 3 plus 4x. Okay, now let us now swap the values. Let us make x on one side, the terms involving x on one side, and the constant terms on the other side of the inequality. 2x, oh, I have to use a freehand. Okay, so it is 2x minus 4x. Whenever you shift your terms, just the terms on either side of the inequality, the sign is not going to swap. Keep this thing in mind. Okay. Alright, so if you multiply, divide with a negative number on both sides, only in that case sign reverses, otherwise not. So now you're having negative 2x and you're having negative 4. Okay, if you multiply both sides by your -1, or if you divide both sides by your -2, same thing. So if you divide both sides by your -2, the sign reverses, as I told you. Because a negative number there, it is, -2 is a negative number, that's why the characteristic applies, and this is it. This is your solution. Express it on a number line. And also I'm going to tell you how to express your solution in a builder notation set. Okay, so I'm just trying to draw a number line here. All the numbers which are greater than 2, once when they are substituted in the given equation, it is going to be satisfied. Alright, so I'm using the freehand, and my 0 is over here. That's my 1, minus 1. That's my 1, that's my 2, that's my 3, and so forth. All the numbers greater than. So this is my 2, and you can see that you're not having equality attached to it. So you're going to put a hollow circle on 2, and then all the numbers which are at the right side of the 2, they are greater. We'll put a line. They are representing that they are all included in the solution. So first of all, just perform a small check, and then we are going to write the solution in the set form as well. So let us do a tiny check. Okay, let us make a tiny check, and if I pick any number greater than 2, for example, if I pick 4 here, I'm going to substitute 4 in this inequality. So it is going to be 2 into 2 plus 7 less than 3 plus 4 times. I'm sorry, it's 4. I'm sorry, extremely. It's 4. And I just wrote 2 here. I'm sorry. It's 4. I have selected 4 here. So it is 4. Okay. Now it is 8. 8 plus 7, it gives you what? 15. Okay, and 3 plus 16 gives you 19. So you see your inequality preserves. 15 is less than 19. So all the numbers which are greater than 2, once when you substitute in the given inequation, it is definitely going to be satisfied. Okay, so now just express your solution set in a builder notation form. So I just write solution set in short, but you must not do this. So okay, set of all x such that x is greater than 2. That's how you express. So all those x which are greater than 2, they are the solution, and that's it. Okay, I hope it's clear. Question number 27. I'm at the left side of the snapshot over here. I'm going to do the work. 27. And over here we are having greater than and equal to notation. Okay, so 27. Question 27. This is it. And now what we do, okay, now 2x minus 7 minus 1, I'm sorry, 2x minus 1 is greater than and equal to 1 minus 5x. Okay, so let us swap the terms involving x on one side and the constant terms on the other side of your beautiful inequality. So it looks something like this, and you're having 7x greater than equals to 2. So x is greater than and equals to 2 by 7. What is 2 by 7 here? Can you let me know? 2 by 7, if I just ask you to write in decimal form, though there is no such need, but just for enjoyment, what is your 2 by 7? Okay, it's 0.285. Okay, I'm rounding. Alright, so this is it. So if I ask you to express your answer on a number line, and this number line thing, representation is very important through your exam's point of view. So if we just draw here a number line, and if whenever you just find out a fractional answer in fraction in your inequality, how you're going to represent it, you see it's much better to just write down like this. Like if you're having 0 here, it's 1 by 7, that's 2 by 7, okay, that's 3 by 7, that's 4 by 7. You keep on going till 7 by 7, you just achieve your 1. Okay, that's what exactly how you represent. You just divide the distance between 0 and 1 into 7 equal parts. That's what it means. So each part represents the 7th fraction, 1 by 7. So this is it. That's how you just do. Okay, so all the values which are greater than or equals to 2 by 7. So greater than or equals to, it means you're going to put a solid circle because this number is included. Greater means you're going to highlight the lines which is at the right side of this number. So it is going to be this. Okay, so this is the representation, and if I ask you to represent your answer in builder notation form, in set notation, we just write down that set of all x such that x is greater than or equals to 2 by 7. Alright, that's how you do it. And this is something that you have done several times, and I hope it is now very, very well revised in your mind now. Okay. Okay, so 36 contains some decimal things, decimal coefficient, constant is also in decimal form. So no need to get confused in that. You just have to apply the same strategy, same concept. Okay, and just you have to be careful in addition and subtraction because there's a decimal thing involved. Okay, so what we do here is question 36. Okay, and this is 15.6 minus 1.3x is less than negative 5 by 0.2. Alright, so how about if we just shift this constant thing on the other side? So it becomes minus 1.3x less than negative 5.2 negative 15.6. Now you are going to apply here a negative addition, so what it is giving you? It is giving you negative 20.8, am I right? Okay, now you're going to multiply both sides by a negative number, I mean negative 1, just to make it positive. Or also you can divide both sides by negative 1, same thing. So I'm not going to show it now because it is too clear. Oh, it's 1.3x and I wrote 13.x. Look at me. Let me just rectify. Okay, so it is now, once when I divide both sides by my negative 1, it is going to give you this. Reverse the sign, it becomes 20.8. Alright, so x will be greater than, x is greater than 20.8 upon 1.3. What it is now? $20.8 21.3. Yeah, it's 16. Beautiful, that's right. So it is 16. So it means that your x is greater than 16. Okay, so now if I ask you to just represent your answer on a number line, now I need you to draw a number line thing on the board. You can see the option, you can use it, take the line option there and just try to draw it, and I'll keep on pushing you wherever you get stuck in while using the tools. Okay, so you should be active on the sideboard too. So this is the builder representation, and that's it. Yeah. Now you have the line option. You can see the option right below the pen. You have to click on it, then it will get active. presently it's passive. Yeah, that's it. That's it. That's it. Now again, just make it passive once again. Use a freehand. That's it. That's it. You can simply write 0 here, then put some nice dashes, and you can put 16 over here, and then you put a circle, and then you can overlap with some different color. That's it. And keeps on going. So now you're going to overlap it. You can use a different color, line option, and a heavy stroke, and this is it. Don't color the circle because you're not having greater than and equal to sign here. 16 is not included in the solution. Yeah, that's it. Okay, so that's quite well. Okay, now let's see the next question, where the question is. Okay, 38. So how about if I just move this snapshot a bit upwards? Instead of upwards, how about a bit right side? Okay, now making it more right. Now I'm here. I'm going to do 38 for you now. A less than and equal to option. Okay, question number 38. Let's do it here. It contains -8. It says -8 is less than or equal to negative times 3x plus 5, and it is less than 13. Okay. Okay. You are having two inequalities here, alright? You can see it. So in that case, what you do, you're going to split up this inequality into two halves, into two inequalities. First one is this: 8 is less than and equal to negative 3x plus 5. That's what you're going to solve. And then negative 3x plus 5 is less than 13. That's it. Okay, so now -8 is less than or equal to, let's apply the negative signs. Negative 3x, negative 5, -8 plus 5. I've just moved this thing, and it is less than or equals to -3x. It's going to be -3 less than or equals to -3x. If I divide both sides by my -1, or I must say with my -3, if I divide both sides by my -3, sign reverses. Okay, like this. So it is 1 is greater than and equal to x, just like that. Okay, and I'm going to close this in a box, and now I'm going to come on the next part of the equation. Let's try to solve this thing here. I'm going to solve it with a different color to make a distinction. It's -3x. Oh, forgot to undo the rectangle. Okay, now it's fine. And -3x, -5, less than 13. That's what it says. So -3x is less than 13 plus 5. I hope it's fine up till now. And it is giving you 18. Now you just divide both sides by your -3. Once when you do this, what happens? Inequality reverses. It happens like this. And it is giving you x is greater than minus 6. Yeah. So let's close it in a box. So you see, these are the two things that you are getting after solving this inequality. After solving this inequality, you're going to combine these two solutions. So how you're going to do it? You see that your x is less than 1, okay, and x is greater than -3. So if you just combine these two things, how you're going to write it down? You just say that -6 is less than x, and x is less than or equal to 1. Am I right? Because you can see that 1 is greater than x, it means x is less than or equals to 1, and -6 is less than x. So if you combine these two, you're getting this range of numbers, okay, which are lying in this range. So all the numbers which are lying in this range, once when you substitute them in this inequality, it is always going to remain satisfied. Okay, so how you're going to represent this range or this solution in a set notation? You say that set of all x such that -6 is less than x and x is less than or equals to 1. And if I ask you to represent it on a number line, what you do? You just draw a nice number line. Okay. This is your 0. This is your 1. That's your -1. And that's your -6. Okay, so you can see here that -6 is not included. All the numbers which are greater than -6 and less than or equals to 1. So put a hollow circle on your -6, put a solid circle on your 1 because it is included, and all the numbers which are between these two, you're going to highlight this line segment. So that's how it looks like. Okay, all right. So in the same way, you should do all these questions which are here. Have I sent you the snapshot on your WhatsApp of these questions? Okay, I'm going to send it to you. You just save it somewhere and try to practice it. Okay. What's the next thing? We are now going to do what? We have just done the first two parts of your chapter 9. We have just learned how to solve the simple linear inequalities in one variable and how to represent solution sets on a number line. Now we are going to solve linear inequalities in two variables, and then we have to find out the solution set. Okay, so after that you have to represent a region on a graph that satisfies inequality. So a graph thing always comes whenever you are dealing linear inequalities involving more than one variable. Okay, so in that case the concept of graph and shading the region comes. Whenever you are dealing linear inequality involving one variable, over there's no graph concept. You just have to express your solution set on a number line. Okay, so in your syllabus you are dealing maximum linear inequalities in two variables, and that's it. So now we are going to learn how to figure out such kind of inequalities and then how to represent them on a graph. Okay, so let's try to manage a couple of questions here. So now we are having a question Oh, okay. So we are now having a question 2x plus 3y greater than and equals to 6. Okay, so I need you to maintain a graph and shade the region that contains those points which satisfy this linear inequality involving two variables. You can see that the degree of this inequation is O. Yeah, I hope you can hear me. Okay, so you can see here that the degree of this inequation is 1. So this is a linear inequality involving two variables. So you have to maintain a solution of it. How you're going to do it? So for that purpose, first of all, you can manage here an equation. So you are going to do it in a step form, in a step-by-step form. So this is going to be the equation. This is the first step of the solution. You have to reduce this inequality into equation first of all. Okay, now obtain at least 2 points. So you can maintain the x and y intercepts of this equation, and then we are going to plot those points on the x and y axes and get a straight line. That's the first thing that we have to do. Okay, so let us see what we can do here. For x equals to 0, the value of y is going to be what? It's going to be 2, of course. So the value of y is 2. Okay, so you can see that here your y-intercept is 0, 2. That's your 1 point. And that's equals to your xy. You can call it like this. And for y equals to 0, this is going to represent your x-intercept, of course. It is 2x plus 3 y equals to 6. This gives you x value 3. So it is x equals to 3. Okay, so you can see that the x-intercept over here is equals to 3, 0. Okay, so you are having 2 points now. The x and y intercepts, we are going to plot them on a graph, and we are going to get a straight line. That's the first step of our work. Okay, so now over here I'm going to manage a graph. Okay, that's what the graph is. Though the grids aren't full square, they are in a strips, rectangular strips. Okay, but still they are the grids. Okay, now we are going to plot these points. 0, 2 is over here. 3, 0 is over here. That's your 0, 2, and that's your 3, 0. X-intercept, that's your y-intercept. Now we are going to join these points and extend it on both sides. Make a nice extension. Okay, this is the line that is representing this equation, okay, that we just written over here. Now what the question is, we have to shade the region that satisfies this inequality. Okay, so how we are going to manage the region over here? Is it this or is it this? Okay, so we have no idea. We have to check this thing first. Okay, so one point above, which is 2 and 7. Another point which is -2 and -3. And at least one point which is lying on this line. So how about if I could pick either the intercepts or any other point if I want to. So how about if I pick the intercept, this point? It's 3, 0. So now I'm having 3 test points. One point is this, another is this, another is this. Okay, so I'm going to now check these 3 test points and let's see it satisfies or not. Which one satisfies? So I think over here we should do it. The inequation is this. Now the test point for 2, 7, let us substitute and let's see if it's maintaining or preserving this inequality or not. It is this 3, 7 is greater than or equals to 6. Of course it is satisfying. It is 4 plus 21, that is 25, and it is greater than 6. So it is satisfied. Okay, let us check 3, 0, and definitely it is going to satisfy because it is resting on the line. So if we just substitute it in the inequation, it is 6 and is equals to 6. Okay, so that's satisfied. Now let us check the last point. So for -2 and -3, -3, see, is it greater than or equals to 6? Is it satisfying or not? -4. It is satisfying. It is. So you see, it is not greater than 6, it is actually less than 6. So it is less than 6. So it is not satisfying. So this point is not satisfying while the first 2 points are. So the region that is going to represent the solution, or the solution region I must say, is actually this. All the points which are lying above the line and on the line, they are satisfying your given inequality involving 2 variables. So you are going to shade this region gently and you are done. Okay, so that's how you just shade the region. My shading is too horrible, but I hope you can understand. You can put a nice color and you can fill it up. Okay, so that's how you do, including this line, because all the points which are lying on the line, they are also satisfying the inequality, because in the inequality you are having the equality attached with the greater than sign. That's why this is an inclusive inequality. Alright. And how you just represent your solution of